Hello everyone, I hope you are doing well. In this video we are going to solve this question. The question says the equation of a plane in a cubic lattice can be expressed as x plus 2y plus z equals 1/2. This is the equation of the plane and we are given with it, and in part A we have to derive the Miller index of the plane. Okay, the equation of the plane is given, and using this equation we have to determine the Miller index of the plane. And in part B we have to determine the normal direction of the plane. Okay, the vector that is normal to the plane. Okay, so these are the two things that we have to do in this question. So let's start. Here is the equation of the plane that we are given with, and okay, let us call it as equation number 1. And in general, the equation of plane is given by following point intercept form. Okay, in mathematics we call that specific equation as point intercept equation, or you can simply call it as a equation of a plane. Okay, it's up to you what kind of description you want to write. And we have x over a plus y over b plus z over c equals 1. This is the general equation of a plane where a and b, c are the intercepts to x, y and z axis, intercept on x, y and z axis of a plane. Okay, for a plane. Okay, in order to find out the Miller indices of the plane, okay, we need to find out the intercepts, and by comparing this equation with this general equation we can get these intercepts. Okay, here a, b and c are the intercepts of the plane whose equation is this one. Okay, so let us write equation number 1 so that it takes this form. Okay, and after comparing we will get the value of a, b and c. Okay, we will compare both of these equation, and in that way we will get the required intercepts. So x, we have x plus 2y plus z equals 1/2. So here it is 1, so we want to make 1 right there, and for this we'll take 2, which is in division process here, to this side of the equation, and it will be multiplied with each of the value here. This is z, not 2. Okay, so it becomes 2x plus 4y plus 2z equals 1. Now we'll leave x alone, y alone and z alone in the numerator, so that the rest of the thing will be taken into denominator, and for that purpose we'll take 2 in the denominator and it will appear like that. Okay, its reciprocal will appear, so that if we take this right here it will become 2x. Okay, so we can write it like that. All right, and now if we compare, let us call it as equation number 2 and let us call it as equation number 3. Comparing equation 2 and 3, you can clearly see here that we have successfully wrote this equation in this form, and you can see here x over a quantity which will be a here. Okay, and a will be the x-intercept, b equals 1/4 will be the y-intercept, and c equals 1/2 will be the z-intercept. After comparison we can clearly see the intercepts. Okay, so these are the intercepts of the plane, and the next step is to take the reciprocal of the intercepts. In order to find out the Miller indices, we first need to find out the intercepts, and after that we take the reciprocal of the intercepts. And after taking the reciprocals, if there is no fraction involved, then the final result will be the Miller indices of the plane. So we'll take the reciprocal, and taking the reciprocal will give us 2. Okay, taking the reciprocal, it will give us 2. Reciprocal of 1/2 is 2, reciprocal of 1/4 is 4, reciprocal of 1/2 is again 2. So there is no fraction involved, hence round bracket 2, 4, 2 are the Miller indices of the plane. Okay, that is the final result. All right, in case of planes, we do not divide these Miller indices by further some integers to reduce it. Okay, it is only done in case of directions, not in planes. So we do not need to divide these three Miller indices by 2 to further reduce it into a lowest number. This is not true or feasible in case of planes. So this is the final result for the Miller indices of the plane, and the part A is done in that way. Now for the part B, okay, we need to find out the direction that is perpendicular or normal to the plane. Normal means perpendicular to the plane, to this plane, 242 plane. So the direction in general normal to a plane with Miller indices HKL is square bracket HKL. Okay, so our direction with the similar Miller indices will be perpendicular to the plane with similar Miller indices. Okay, for example, if we have the plane 100, then the direction 100 will be perpendicular to this plane. Okay, so in that way, direction normal to the plane 242 is square bracket 242. Okay, and for directions we know that HKL is equals to the integral multiples of HKL. Okay, so we can further reduce that one number, okay, into a lowest integer, because in case of directions, all of the directions and their integral multiples are equivalent. That is why we can divide each Miller index further by 2, okay, to reduce into lowest integer, and it will become 1 to 1. So 242 or 1 to 1 is the direction normal to the plane 242. Okay, so this is the answer, and in that way the question is done now.